Heisenberg's uncertainty principle. Heisenberg's uncertainty principle states that it is not possible to determine simultaneously the position and momentum of a small moving particle, such as electron, with entire certainty. Mathematically, it may be expressed delta x into delta p greater than or equal to h by 4 pi, where delta x is equal to uncertainty in position, delta p is equal to uncertainty in momentum is equal to m delta v. Delta v is uncertainty in velocity of particle, m is the mass of the particle, h is equal to Planck's constant. So, it can be concluded that one can define the position of small particles. The less certainty one is able to define its velocity or momentum, and vice versa. Significance of uncertainty principle. The effect of Heisenberg uncertainty principle is significant only for motion of microscopic objects and is negligible for macroscopic objects. In case of microscopic objects such as electrons, the interaction of the striking photon of light with the particle will cause appreciable displacement of the particle from its normal path. As a result of this, the particle undergoes a considerable change in its path and velocity or momentum due to the impact of a single photon used to observe it. Thus, the very act of measuring the position of the microscopic particle causes a change in its momentum. The collision of photon with the electron sends it in an unpredictable direction. In our daily life, this principle has no significance. This is because we come across only large objects, that is, the objects which we can observe with naked eye, without altering their motion. The position and velocity of these objects can be determined accurately because in these cases, during the interaction between the object and the measuring device, the change in the position and velocity are negligible. Example: calculate the uncertainty in position of a dust particle with mass equal to 1 mg if the uncertainty in its velocity is 5.5 into 10 raised to the power minus 20 meter per second. Solution: given delta V is equal to 5.5 into 10 raised to the power minus 20 meter per second, m is equal to 1 milligram is equal to 1 into 10 raised to the power minus 3 gram, h is equal to 6.626 into 10 raised to the power minus 34 joules second. From the formula, delta x into m delta V greater than or equal to h upon 4 pi. Uncertainty in position can be found as delta x greater than or equal to h upon 4 pi m delta V. Substitute the value of h delta V m, we get delta x greater than or equal to 6.626 into 10 raised to the power minus 34 divided by 4 into 3.14 into 10 raised to the power minus 3 into 5.5 into 10 raised to the power minus 20. Delta x greater than or equal to 9.59 into 10 raised to the power minus 13 meter. Reasons for the failure of the Bohr model. The wave character of the electron is not considered in Bohr model, and the orbit can be defined only if both the exact position and the exact velocity of the electron at the same time are known. This is not possible according to the Heisenberg uncertainty principle. Bohr model of the hydrogen atom ignores dual behavior of matter and also contradicts Heisenberg uncertainty principle.